It gives me great pleasure to welcome back Colin Penfold from the CICS team in Hurley. And Colin, you were with us last year, I think, for one of our
last year online, and been here the times.
Yes,
in person.
Indeed, and so no stranger to us at GSE. So we hear about zero trust these days, and there's a lot of organisations that are trying to implement it. So it'll be interesting to hear what zero trust means in terms of CICS. So, Colin, over to you. Thank you.
Thanks very much. So I'm Colin Penfold, and I'm leading a team which is looking at zero trust and other security aspects within CICS, and we've been doing that for the last few years. This presentation is going to be primarily, almost actually completely, about zero trust and what it means in terms of changes that we're making within CICS to help you implement a zero trust strategy. So what we're going to cover in this agenda is a number of things which are going to be on the release of CICS that we released last year, which was 6.1. Most of it is going to be new stuff that we've got in open beta. We release open betas every 3 months, roughly, leading up to the next release. And the purpose of this is both for people to prepare on what's coming up, but also to get feedback, because what I'm going to be presenting for the open beta stuff, which is most of this, will be things which are probably going to be in the field, but they may be slightly different when we come up to releasing them. And if you've got any comments about what we're producing, think that it should be slightly different, that's really what the open is about, so we can see those comments before things are released. If it's something that's in 6.1, you'll see a little 6.1 icon somewhere on the screen, otherwise it's open beta. Now I'm going to cover a number of aspects. One of the biggest ones is the thing we call CICS security discovery, and then some other things about zero trust, helping you to implement zero trust. Simplification is a key element of security to try and make sure that what you're trying to do is achievable. And then something called DevSecOps, although it may be more defined as the CI/CD pipeline, and security in the CI/CD pipeline. And finally, if I've got time, if I don't run out of time, a little bit about compliance. So first of all, zero trust. David mentioned zero trust in the first presentation as something really important in terms of the current environment of hacking by either state agent or criminal gangs. Now, what you won't find in the open beta is anything which says this is a switch that you switch on to get zero trust in CICS. Isn't the nature of zero trust. Zero trust is a strategy, it's a way of thinking about your security on a system. And I've got this quote that's on the IBM homepage, or just the IBM homepage, about zero trust, which I think describes it nicely. It's a way that you implement your security strategy that you need to think in slightly different ways. It's different that you're not thinking in the ways we used to think about bound security. You're very much thinking more about what's going on inside the organization. Assume that you've got a hacker that's got into the organization, or you've got a bad actor outside the organization. So what is it in terms of key elements of things? The statement that you'll see all the way through my presentation is it's in making sure that the right user has the right access to the right data for the right reasons. We've come from an environment where things are slightly more permissive, that you may request things like one person comes into the organization and say, I want access like Fed's got access, and in that access. You're not really looking at why somebody has access. You need access to certain things, certain data for your job. That's what the purpose of that is. And it's trying to make sure that that is the reasons why you're given access, and make the access you've got even access. That stage is never trust, always verify. Part of some of that was what was talked about in the first presentation, MFA. We've had MFA in CICS for several releases, we're including in ZOS. So we're okay with that one. And then the next part of it, very important, is assume the bad actor's already there. What can you do to monitor what your data? Now, the things I'll be talking about in this presentation, these are the sort of 6 elements of zero trust: identities, devices, applications, infrastructure, data, and networks. In terms of what this presentation and enhancements we need to make to CICS, you're looking at identities, data, and applications. CICS is all about running your applications to access your data and making sure that that is accessed by the right people. We did some research about 3 years ago, before zero trust really came in as something in the forefront. But it came in about 2 years ago with a White House directive about zero trust, and a lot of people started getting interested about that, especially auditors. But we started looking a bit before that, and we were looking about how customers can get security on their system. And what we found that transaction security was universal on the customers we talked to. But customers don't configure many of the other security parameters that we have in CICS. The resource security. When I say resource security, I also will mean command security. A lot of them do not have any security until just the pre-production. And automation is very, very limited in what we've seen. There's sort of replay type of automation, but very limited automation, especially in the test area. But at a recent conference with customers, we discussed what their strategy was for zero trust. And I think all bar one of the people that we spoke to said that they were going to do it in 3 to 4 years, which will now be 3 years, because it was nearly a year, half a year ago. We do to implement zero trust on CICS. We've got a set of things that we're looking at here. The first one to be talking about is security discovery. The reason for that is you've got an environment that was set up possibly in the 1980s. Some of it was even set up before VACF was available on mainframe. And some of those definitions may not have changed. People don't like looking around with a lot of the definitions. If you touch a definition, it may break something. You don't want that to happen. So what our first stage is how do we help customers go from where they are now to the settings that we'd like them to have? And also help them estimate the cost before they switch on the security, how much this security will cost if you're doing security for your data or your critical data. The next part is a bit of a legacy thing, but CICS has lots of controls. And one of those controls is a transaction can switch off root security and command security, which means the system programmer can switch off the security programmer has set up, which is not something you'd have done nowadays. It was something that was done 40 years ago. We need to sort of change that so that customers have resource security switched on for just about all transactions. It's something that in PCI compliance, it's very much recommended. So how do we do that? Next stage is once you've got your system set up, how do you maintain it? How do you ensure that application changes, new applications conform to the right security without breaking things? And finally, if I get to that, how do you check? So first of all, security discovery. So transaction security is really sort of boundary security. If you're allowed in to run the transaction, how do you know what goes on inside the transaction? Can you trust that transaction that may have been written by some developer that's not part of your organization? It may have been written, it may have been outsourced. It may be an insider that's running something like that. How do you ensure you know what's going on inside that transaction? How do you monitor what's going on? Zero Trust really emphasizes it's the data that is the important thing. So all you're doing by transaction security is allowing somebody or not allowing somebody to run a process. You're not actually securing the data. If you have 2 transactions, one of which you're not really sort of very careful with looking at on a system, and one that you are careful, the one you're less careful with could be accessing data, any data that is on that region, unless you secure the data by resource security. And as I mentioned, you're trying to make sure the right user has the right access to the right data for the right reasons. What do we mean by the right reasons? Well, in terms of RACF, I'm talking about RACF, but the solution we're doing would allow the Broadcom products also to use it. The right reasons means a user needs access because of the role that they're in. And a role in RACF terms means what groups you're in. You shouldn't have access personally. You should only have access for the role that you're in. But a lot of people haven't necessarily set up roles. From the customers that we've talked to, there's a mixture. Some are perfect in having roles for everything. Some have got a bit of a mixture, user access, and some, because of the way they've done their security and get access, have got no roles whatsoever. So no groups at all. So how do we try and encourage and try and help customers move into a model where you can use groups, you can use resource security? So as I say, customers at the moment have this as their setup, and we want to go to nextran equals yes, and file control equals yes, and whatever other data sources equals yes, so that you've got security checking done on those setups. But obviously, you don't just switch on the parameters, you've got to get the security definitions correct. So how do we enable customers to migrate to that resource security without breaking their applications? Because that is a critical thing. Because if we come up with something and the applications break, we're not going to be popular. The system program is not going to be popular. And from the customers that we've worked with, a couple of them have tried to implement all of this themselves using existing tools, and the projects have failed. Without tooling, it's too difficult. So what we've come up with is something called CICS Security Discovery. And this is a four-stage process. And there's going to be sort of instructions about how you would go about implementing this. But there's some tooling involved in these stages to assist customers with going from a stage where they haven't got resource security to a stage where they have got resource security and can enable it in a safe way that should have no outages or minimal outages to try and minimal errors where somebody hasn't got access to something they should do, but so can't access the application. So we're going from here. The stages are, first of all, we translate their RACF data into some ESM data, as we call it, so it's agnostic to which security manager that it comes from, so that we can support the Broadcom products as well. So we've got this security metadata, which what it contains is information about all of the CICS security that is on the system in RACF. We then do something called discovery, where on the CICS regions, we run something which has a look at user accesses to all the data that they're using over an extended period. Because users aren't going to run everything on one day or one short period. They're going to do it over an extended period. And it may be the case where you run it for a period, then stop it, run it at end of quarter, end of month, end of year. So you capture all of the user accesses to all of the transactions and other data that they're using. That data is then fed into a new editor in the CICS Explorer, which the system programmer uses in conjunction with application owners to analyze this data. And a lot of this analysis, as I'll show you, is done by us so as to give you suggestions of what the security should be. Then finally, the data is output into new RACF classes, which you can then use on your CICS regions to switch on the security. They should be fairly correct out of the box, but we'd recommend some sort of warning mode on there so that you can get them right over a short period of time. The question is, does it work? Does the security discovery just work for RACF? No, it works for all of the products. The way that we hook into things is we're not hooking into RACF, we're hooking into the internals of CICS, so it will work with all of the products.
So how would it work for like an ACF2 part?
What
Safe lists and things like that?
what it is covering is it doesn't cover absolutely everything in the security definitions. What it will be covering would be the equivalent in RACF terms of who has access to which resources, what groups you should be in, what lists of transactions or other resources make up an application. And then in the security metadata, the provider can transform that into the relevant palms that are required or definitions that are required for the different products. So the reason we've done it in these stages is to allow the other products, not just RACF, to transform the data. So it's, as I say here, it's security metadata rather than security definitions. So we're trying to be as agnostic as possible to things.
Yeah, does SMF capture this data though as well? User profile,
it would capture it if you switched it on and you didn't enable everything. The trouble is, at the moment, we're at the stage where it's not enabled. And it may be the case is you've got definitions on here for the transactions which switch security off. And we still need to capture the data for that. And that's going to go nowhere near an SMF records. It's going to go nowhere near anything.
Yeah.
Even Broadcom would never see that.
This is belts and braces then against all the regions.
Absolutely. It's making sure that we've got everything, including bad definitions or definitions that we wouldn't recommend. So I'll go through the various stages on here of what we're doing. First of all, very straightforward process. Here's an example for our RACF example. So you're capturing the data, you're extracting the data from the security database. And what we're looking at here is we're looking at the transaction class, that's showing that information, because that's the one that have generally got on their systems already. They generally have fairly well defined. Look at the transaction class, look at the various profiles that you've got in the transaction class, so the groups of transactions or the individual transactions in there, and the accesses and what groups or users have access to those. And then we have a look there of the list of groups, who's in each group. And so you can quite easily understand what that information is if you know any RACF. And I think somebody recognises a certain TV program. I needed to work out something that described a manager and a teller, so. So we're extracting the basic information, and that information is then put onto a file that is an ASCII file that can be read by the Explorer. The next stage of it is capturing your data for all of your running regions. Now, we're capturing data looking at all security that either is done or would have been done had you configured it on the CICS regions. So we're looking inside. And you may have switched things off. You may have switched things off at the transaction level. You may have switched things off at the class level. We're sort of ignoring that sort of level of information. We're looking to what did the user actually try and access? With what level? We're obviously ignoring things where you don't have access. And if you don't have access because you've already set up security, they may have tried it, but we're not recording that information. And we're recording it in memory. So it's quicker than doing it in the SMF. We're recording it in memory. We're recording it once to say, a user needed access for this. Once a day, we'll write, or on request, we'll write that out to a log stream to capture that information. We do that for each of the regions. And then after a period of time, that log stream can be extracted. The information from the log stream can be extracted. And what do we record? We'll record what resources each user ID accesses, what levels, and we also record what resources each transaction accesses, because that information may be useful. So that's the SPI for the discovery commands. We basically switch it on and say what classes you'd want. one of the things you want to know when you're capturing data, there's a small cost. What we've measured on there is it's only 2 or 3%, I think, for the moment, and it tails down once you started capturing data. So it's something that would be acceptable on a region. But we also have information that is written out periodically, or you can inquire upon to say, have I seen anything new? Because you've got, you know, when I had kids, we've always got the, are we nearly there yet? Question from kids. You want to know when you've captured data, you don't want to leave it on for months and you're not actually capturing any new data. So it'll tell you if it's seen anything new in the last period of capture. So you know when to switch it off and you've got enough data. When you print things out, you get some stats. That's a fairly small system, obviously, that we're running things on. That information will be useful later on when we show you how to estimate the cost of switching on the security. You've got an estimate that we have from your existing security, switching on transaction security. We've got some performance information that we covered in the IBM doc. And from this, you'll be able to work out the extra number of checks that you're likely to get by switching on different types of security on each of the regions. So you can work out from that what the cost is and do your balance of whether the cost and the risk are affordable. So that rather than just switching it on, suddenly finding the CPU's gone up a ridiculous amount, you should know before you switch it on. Finally, the big part of this is the analyzing the data using the CICS Explorer. So there's a multi-stage process, which I'll show you here. The first bit is just making sure that your transaction settings are in a good state. Most people have got transaction security, but that transaction security may have been set up so that certain things could be improved. So we'll show you that transaction security to start with. Then we use the data, the security discovery data, we embed that and show you, not in conjunction with the security data, how people have actually used different resources that you've given them. And start off with transactions. And then the third stage, which is not yet in the open beta, is that you would use then the information that we captured for the resources. And so you can see what security definitions you should define for each of the resources that you use. So this is the new view that we've got in the Explorer. Here we've imported some definitions. This is some sample data that I generated. And what you can see here is that it doesn't look as though there's any pattern. The way that this data has been written, we didn't use member lists, we didn't use group lists. So as a consequence, it looks really messy. Now you've got an option that you press on the Explorer. I've only shown the main panel, I haven't shown the whole thing, otherwise it gets a bit too small. But there's an option that you click, which says Analyze. And what this will then do is it will do cluster analysis to look for patterns in the data and try and do a best fit. Alternatively, you can do cluster analysis using exact fits, where people have exactly the same security access. But normally we would recommend using a best fit analysis. And so doing this analysis, when you press that, what the analysis does, and this is genuine data that we've done by using the tool, it identifies what it believes are groups. And those groups, you can see here, have similar access. It also identifies member lists, i.e. groups of transactions, which would probably be in the same application. Down here, you'll also notice question mark. What that one means is if we put this user in this group, they will actually, and you accept that, they will actually gain access to this resource. So that's a decision for the system programmer in conjunction with the application owner of this application to say, do you agree with that, that user should have access to that resource? you've got various buttons on here so that you can click those and say, yes, I agree with that. And you, by clicking that, say, yeah, I agree with everything that that user's got. And also, as a fast path, you've got other ways of saying, yes, I agree with that data. Now, what you might do, though, is say, I don't agree with this person. This person's in the wrong group. I know that that person should be moved. So you move that person to another group. And when you move that person to another group, that access sort of disappears because they didn't have that access originally. But then there's a question there to say, well, if you move them to this group, they then gain access to this resource. Alternatively, they lose access to this resource if they're put into that group. So you can see graphically on there, when you're changing things, very easily what the impact is of moving somebody to a group. So that's using just the RACF data. Now, the next stage is we import that discovery data that we've got. So the discovery data is been run on one or more systems. You wouldn't do this over the whole of your system all in one go. You'd obviously subdivide systems so that you can do it sort of sets of regions, applications at a time, something like that. So you're importing this discovery data from the regions that apply to this, this setup. And what the discovery data say, you've got these little r's, and those little r's say that this person has got access to this transaction and actually used it during the period. Or alternatively, this person's got access but didn't use it. So then you need to make a decision, well, is that okay? Do they not need access to it? They've never used it during that period. And again, that's the sort of discussions between the system programmer and the application owner. As you go through, you resolve the changes and say, yes, I accept all of that. So you get to the stage where everything has been accepted. Yes, we like all those definitions. And also the other part of it is, as you go through these proposed groups, if you haven't got groups of your own, you can then give those groups names. If you have got groups or transaction lists, we'll obviously honour those because those are things you've currently got. We don't change anything that's currently there unless you want to move it yourself. Once you've done that, then the data is converted into that data is saved, and that data then can be converted straight to RACF definitions, or if Volcom provides something equivalent, a Volcom set of definitions. And what we would recommend then is the way you would run this is you wouldn't modify the existing group. You'd create new groups, new classes, and then that would allow you to restart your regions with a new class. But if you've done something wrong while you've been going through this process, it's dead easy to back out because you just changed the class. So if you do that, along with having your sort of standard warning mode that you would normally do if you're implementing something new on those new definitions, you should get something that doesn't break anything. So halfway through on there, I mentioned to start with that this predicates the fact that you've got command security on your transactions and resource security switched on, because for historic reasons, we have got command security and resource security on the transaction definition as well as on the SIP parameters, which allows the programmer to override things. And unfortunately, 40 years ago, one of my predecessors decided security off is the best default for this parameter. It's not on the case of CICS, but yeah, we wouldn't do that today, but that's what's there. So how do you go from that? Now, I know a lot of customers do make sure they've got processes to make sure security, resource security and command security is on if they are using it. if you're not using resource security, you may just leave the defaults. So how do we do that? What's even worse, unfortunately, is most of our CICS transactions also default to no, which again is not a good idea. So what we've done is change everything to yes for our CICS transactions. But we couldn't just switch it on to say yes, because that would be that could potentially break you if you've got any security currently on your systems. So we've had to do quite a lot of work to make sure that those transactions are fit for purpose. And I'll show what I mean here. Next slide. Or alternatively, if you need additional security, we are very clear on what security that you need. And so we've got a new page which in one place tells you all the security that you need for all of the CICS transactions. So you don't have to go hunting around each of the pages of the documentation to try and find, what do I need for this transaction? What do I need for that other transaction? It's all in one place, so that you've got a single source where you can start off with and find all the security definitions for each of the transactions, CICS transactions that need security definitions. An example of the sorts of things you've got here is I've got two examples, simple examples. Hickey, where a user can issue any command they like, API or SPI command. Obviously, that is not what you'd call a trusted transaction. You have to have command security for anything that the user does and resource security for anything that the user does. But for the point of view of some other transactions, the other transactions are effectively sort of encapsulated. Our code is trusted. Well, I hope you trust our code, because otherwise the rest of it doesn't work. Now, as long as a transaction is totally encapsulated, you can't get in any other way, you only need the transaction definition. You don't need anything else. So certain transactions we've had in CICS require many definitions in order to perform the action that a transaction has. An example of that sort of thing is sign-off transaction. If some sign-off fails, the way it works is it writes to a TD queue, which does the security check, are you authorized to the TD queue, in order to give you an error message. So you have to authorize every single user of the sign-off transaction, which is basically everybody, to write to a TD queue, And if you've done that, you've given everybody access to write to that TD queue from everywhere. So that's not particularly secure, because somebody can just write random messages to that TD queue. Really, the thing that you need is this transaction doesn't need authorization to write to that TD queue. And there are other things like that, like the shutdown transaction. In order to run the shutdown transaction, you need to give them authorization to this, that, and the other. And you shouldn't need to do that. You're either authorized to do the shutdown or you're not. So where there's a single role for a transaction, what we do is we make sure that the transaction is encapsulated completely, and the only security you need is transaction security. So that's what we've done for the CICS transactions to make it easier for you to switch on command security and resource security at the region level. What we're looking at the moment is making sure that you can switch on, that we can change the default from resource security no to yes. At the moment, that's not there in the open beta, but that would be our long-term objective. What it won't do, obviously, is change existing transactions. We don't want to modify your existing transactions because that could have hidden implications. But security discovery will give you the information so that you can then be sure on a transaction by transaction basis which transactions have got all the security that you need so that you can change that value. Ultimately, you would want to switch resec equals always and command sec always, which means basically you're taking away the syspog's ability to switch off security. You've now got something that resource security is done on all of the transactions, regardless of the transaction setting. The reason for the preceding work on about the CICS transactions was because if you did this, you'd actually break the CICS transactions. So it can be well, unless you've got the security defined. So it's better to go in this staged approach. You get all your transactions right, and then switch on this to make sure you're future-proof. I believe that's the case. Yes, you can look at the question. The question was, when you in CICS Explorer, have a look at all those definitions. That is correct. Yes, you can do a display to see the security, provided obviously you've got CPSM on your system, so as to have a look at the whole regions, do it on a one-by-one basis on each individual regions. Yeah, so that's one way of doing that activity. And I think that's what we'd recommend in the Centre for Internet Security, the CICS guidelines for PCI. I think we recommend you use that process. So, got to the stage where I've talked about the command security and the discovery. There are other changes we're making, because what we don't want you to do is have an absolutely huge number of security definitions. We're also looking at where are these security definitions not really required. Sometimes, and this is something that we started in the last release looking at, sometimes adding security definitions can make something less secure. That seems perverse. Yes. And I'll show you an example of that. In fact, a couple of examples. Again, we're still talking about the open beta on here, but I've got an example that was in the 6.1 release. So, terminal security. Now, terminal security applying to 3270 terminals. Often, you have on a 3270 terminal a need to change from lowercase to uppercase. So, on a sign-on transaction, when we had passwords which were mixed case, we had to modify the program, which was the sign-on program, which uses API and SPI commands, change security to say switch on mixed case so that you can enter a mixed case password, because terminal was uppercase. However, to do that, what you needed was a set terminal command. And because you were using the set terminal command, you needed update access to terminal commands. And you needed that for all users of the command. Now, for a sign-on command, obviously, you aren't signed on, so that's the default user. So that meant even the default user needed set access to the terminal command. Unfortunately, the set terminal command, as well as doing uppercase and lowercase, has got some really powerful features, like it can purge another terminal. So you can purge everybody on the system, which is rather too powerful for the default user, for somebody who has it logged on and you don't know who they are. So that is a real dangerous security definition to do. So we had to think about that and sort of, well, that is really dangerous. How do we change that? Well, should you really need, or should an application need, permission to change its own terminal? Well, no, not really. It's only affecting you, and it's only affecting a subset of things. Obviously, what you don't want to do is to affect any system facilities. So what we've done is we've moved security check-in when an SPI issues a command for its own terminal to say, right, you don't, if you're issuing one of those commands, you don't need security checks. There are certain things that a terminal can do, supposedly for its own terminal, which are rather more powerful. You know, doing a purge, even system activity, is not something that a user transaction should do. So you still get security checks for those, but you don't get security checks for the basic things. And so you don't need for every single user, including the default user, in order to use these facilities. So again, this is removing security definitions makes it more secure, because you are giving security to do a small thing, and you actually, by doing that, you give it wider powers. An even bigger one was, which is one that auditors like to look at, is the Cat1 transactions. So for years, we've had this C list to define the region access to Cat1 transactions. And auditors like to look at this because it's an easy thing to audit. Of all regions got access to Cat 1 transactions? Has anybody that's not a region got access to Cat 1 regions? Now, this causes quite a few problems, and customers quite a few problems. One, because if we added anything in service, we sometimes accidentally missed doing an update to the Cat 1 transaction list, or alternatively, people forgot to run the C list to update things. Set prefixes are a nightmare with Cat 1 transactions because you've got multiple definitions of things. But going back, what was the actual requirement? Well, the requirement was can a region, only the region is supposed to run a Cat 1 transaction. Well, the thing is, we know what the region is because we're running it. We know what our ID is. We know what the list of category 1 transactions is. We've defined them. We know how the transaction started, i.e. it was started by CICS rather than on a terminal. So why on earth are we asking the security manager, whichever security manager, are we allowed to run part of our code? It was just a nonsense. So basically, we remove the need for security definitions. We do the check internally. If you're not the right person, which is us, i.e. the region, the CICS region, you're not allowed to do it. If you're not starting it internally, if you're starting from anywhere else, any other method of starting, you're not allowed to do it. And you get the bend if you try and do it. So the security definition is not required. It means by doing that, somebody who is not the region ID can't run a transaction they're not supposed to. So again, removing security definitions can make things more secure. And spoke at the security conference in Montpellier last year and had a chat afterwards. I think Michael Jordan, our security lead, sort of, I haven't thought of that one. It's sort of counterintuitive, but you need to think about why are you putting a security definition in?
So it no longer checks.
Well, it does check, but it checks internally. It doesn't check the security definitions. From 6.1, the security definitions are not required. We do what it would have done had it asked the security definitions and you'd configure them correctly. So it means you cannot configure them incorrectly because you don't need to configure them. We'll just get the answer right.
Thinking whether people have configured them and it overrides the internal.
It will ignore, if you try and configure them, it will ignore it because a CICS region that can't run its own transactions is not going to survive very long. So it's allowed to do that. Right, final thing before I get on to DevSecOps is a query security command. There's a command that's been used in menu applications in particular that can query security to say, what am I allowed to run? And you can specify no log on there so that when you ask what transactions am I allowed to run, so you go through one by one each transactions to build up a menu. It doesn't issue the 408 security errors or appropriate ones if you do that. Now, this command is quite powerful because a rogue developer could use that to go through a big list and say, what am I allowed to access? And not only is it what transactions am I allowed to access, what other CICS resources am I allowed to access? You can do any security command, any security classes on there. So it is a very powerful command. Obviously, we cannot remove it because it is something that is very key to many applications. They're building up their menu applications. So what we've done is monitor it. So give 2 bits of monitoring information and stats information, one of which, how many of these commands fail, and the 2 reasons why they fail, you're not authorized, and the other one is I can't find the resource that you asked for. Now, that second one, I can't find the resource that you asked for, shouldn't really occur in a well-written application because a well-written application doesn't go around and randomly select names of transactions that you might want to see. You do define those. So if you get any of these that appear, that's a bit suspicious. If you get huge numbers of these, that's also suspicious. So there's also monitoring on there, so you can do it on a task-by-task basis, so as to have a look where these commands were issued to see whether there's anything unreasonable. Now, this goes round with the Zero Trust continuously monitor. We don't necessarily know what all application programmers get up to, and therefore it's sort of necessary to do some continuous monitoring to make sure that if some rogue person is inside the organization, you can see what they're doing. So finally, as the sort of big topic I've got for zero trust on here is what we call DevSecOps. It's sort of what we're looking at is how to get security right in your development process. What we know, as I said before, resource security is currently not enabled. And one of the reasons for that is it's very complicated for application developers. I'll take you something. The way that that developers get security permissions, often developers don't know what they want. And they go through and talk to system programmers. This is the research that we found. And then the system programmers can then talk to the security programmers to put those definitions in. Now, this doesn't fit with a nice, speedy, agile process where you're doing things, because we all know how long it takes when you're asking a system admin to give you a definition. They don't do it instantly for good reasons. It takes a little while to get through there. They've got to check things. And other problem is generally the first time any of this is tested is just before it's about to go out. Security pre-plot. Another thing that we found in customer research more recently is the amount of automated testing that is done at the development level, and it is very, very limited. Now, this is a statement that I saw a few months ago, which is one of the problems is that the security team don't trust developers. Probably for good reasons. They don't understand security properly. And that's one of the reasons why the mainframe is better than the off-platform, because security is done by a separate team, it's not done by developers in the on the mainframe. So what we've got to look at is how do we help customers to get their security definitions correct first time, before their code is promoted, get the right definitions in a nice, easy way. Now, what we were looking at to start with was, let's do this all through automation. But as I said, automation is not something that is in most customer shops, at least at this sort of level that you need it. So we've come up with two solutions. The one that we're doing at the moment is a manual solution, so that the developers can see what security definitions they have to request. So they've got a sensible package of things that they can talk to the security admin to say, my application needs these definitions. We'll be documenting that so that you can put that in an automated solution, but look out for what's going on in the future. As I say, all of this at the moment is only an open beta. So the process is that you've got for this manual solution, application developer does the code promotion. Then when he starts doing his testing, or when the tester does the testing, whoever is doing the testing of the application at the development level, switches on this transaction. And it's a bit like other transactions that you've got within kits like EDF, something like that, to try and find out what's going on. But this is for security. So you switch this on, you run your tests, you switch it off. When you switch it off, what it'll do is it'll submit some JCL for you. You don't have to do it yourself. And that JCL is submitted via some templates that is put on the system. And that will go to the developer, will be the developer. And the developer can then review this information, this YAML information of security metadata. And that information is nice and easy to raise a request to the security admin so they can make the change, and then the code gets promoted. So let's have a look at that. So you run this transaction, and what it'll come out with is a list of all of the resource access that you've done, what access level you needed. It'll be your user ID because you're the developer that is running this. If you've used multiple user IDs, it'll put all those in there. And it'll tell you for each of the classes what accesses you need. So this information, which I say is very easy to read, I believe, is a much easier thing than the developer saying, Well, I think I read a file, or I called this routine, which, well, I'm not sure what this black box routine does. I think it reads a file. It might update a file. But I don't know what the name of the file is. And you've got all of that sort of discussion that goes on at the moment. This tells you exactly what you've accessed on your system, what access level you need, so it can be reviewed. And when I say reviewed, it can also be rejected. You know, you may have used a black box which does dates to the mortgage account, and you know that somebody's writing an inquiry transaction. So why do you need update access to this particular resource? So it tells you exactly what's going on the system. And that information then can flow up and make it a lot easier to get the right definitions. And so once you've got your resource security set up, it will give you everything you need to maintain that resource security. But that's a manual process where somebody just reads it and sends it. What we're looking to do on here, and here's a way of doing that sort of thing that we've got in the documentation, is you do that process as part of the CI/CD pipeline. And as part of that, if you've got automated testing, you can run all of this stuff, and this output to come out automatically. And by doing that, if you're doing it automatically as part of the CI/CD pipeline, you can have a look and save information as you go. So you save information the first time you run it, and then when you make changes, you run it again, and you get that information. You can see differences between before the code changed and after the code changed, so that what the security person can see is just the deltas. I'll go over to this one if it's hard. You've got the deltas, so you can see the result of this application change is read access for this resource has been changed to update access. And then the security admin can either approve that and make appropriate changes, or reject it and say, no, I don't accept, you should have updated access for that application. So it makes people's jobs a lot easier, because all the system program has got to do now, security program has got to do, is review those deltas. And you can see those deltas in context. That did this using a sort of simple ISPF comparison. So final part of things is something that was in 6.1. You've done all of this work. Now, the auditor will say, well, prove it. And this was something that we put into 6.1, not just in CICS, it's something that's sort of general on ZOS. So the problem that we saw in the last release of CICS and ZOS was the auditing process was a little bit flaky. Auditors generally, they're trying to interpret regulations for our products, and they're not, many of them are not particularly skilled in our products. You know, you get the sort of things that they'll fail you because you haven't got your virus checker running on ZOS. And I've never been able to configure that either. They don't quite understand it. So we did a lot of work trying to interpret this sort of information. Another problem is they collect a lot of information, and their interpretation is really subjective. They don't really understand stuff, which I was talking about the Cat1 transactions before. That was a nice simple thing for them to review because they could understand that. But trying to review whether you've got all your TCP/IP definitions correctly defined for security to make sure you've got TLS defined, that's well out of their range. So system programs gather the information, and it's very expensive to gather the information, and it's very expensive to gather it in a non-reputable way. And I say, interpretation is subjective. So what we've tried to do is come up with a solution where the data is collected automatically from all the regions, and a way of displaying that information. And finally, a way of giving advice to the auditors so that they can interpret that information in a consistent way. So this is something some of you may have heard of, the Z Security Compliance Center, ZSCC. So you can set this up I'm not really going to go through the details of this because I'll talk about the CICS parts. You can set this up so that you can schedule periodic compliance checks on your system. It will send a request to ZOS, which sends out events to all of the listening components on that, including CICS. We will then write information out to SMF, which is collected and sent back to the CICS tool, which will then display in a simple traffic light scheme, comply yes or no. And then if it's no, you can drill down into things. An advantage of this mechanism is all of the data is collected in a non-reputable way because no humans involved in data collection. And also, you don't just do the data collection when the auditor's in. So you switch on all your security parameters when the auditor's in, and you can go back to normal when it disappears. This can be collected on a periodic basis. You can see that sort of maybe on a daily basis and see how you're improving. And the auditor can see how your compliance has been over a period of time, not just on the day that he was there. We do with if you haven't got the CICS. Well, we've got much of the same mechanism. Basically, that's all of the CICS data. You issue a RESTful request to something that's running on ZOS, the compliance agent, and that generates an event which listens for and writes out data, which you can then run a piece of JCL. And what the JCL will produce you will be a spreadsheet of all of your regions. Now, you don't need CPSM to do this. It will give you all of the regions that are running on that LPAR, the LPARs that you selected when you do the RESTful request. And it will give you all of the security information that is useful for an auditor to do a compliance check. So it will tell you the regions, the region IDs. It will tell you all of these set parameters and what values you've got. It tells you whether you've got things on. So these are all sort of all very nice, well-behaved systems, apart from the SEC-No, which does show that it's actually our development system that I collected this data from. But what you'd be looking for is when I've done audits, asking people to get me dumps of all of the SIP parameters for everything. You're trusting that they've done it correctly, and you get all of this information, or you try and get a dump of every single region and look for this sort of stuff. And it is a really painful thing to do. Obviously, if they've got CPSM, it's a little bit easier, but that region has to be connected to the CPSM. This gets everything on the system, regardless of whether using CPSM or not. And you can see everything there. And not just this information. Another part of the process when you're doing an audit is you ask them for the document or spreadsheet which tells you what is the purpose of this region. Is it a production region? Is it a test region? In the last release, in 6.1, we had something called region taggings. So you can build up a single file, which is used, a single YAML file, which is used to define what the purpose of each of the regions. And you can define a nice simple thing on that YAML file to say, this is a production region or test region, and gives the auditor a nice simple way of saying, hang on, you've got a production region, as a test region running on your production regions. That's not allowed under the PCI rules. Tells you region types which may be useful, and you can put anything, any other stuff in the tags as well. It also tells you the most recent 5 PTFs. There's another thing that an auditor will be looking for is your system up to date with security? Well, you can show them your SMF data, your SMP data, but that doesn't necessarily mean that your CICS regions that are running are using that library. This tells you what you're actually running in that library. So compare that with the SMP data and say, yes, this is actually running an up-to-date region. And along with that, there's a CIS benchmark, which explains to the auditor all of the PCI DSS rules that go along with what the auditor is looking for, how to interpret them for a CICS system, or alternatively for any of the other ZOS systems that work on the CICS. So this information will help you in Zero Trust environment, because you look through this, all of the PCI, all the zero trust recommendations are actually the same as the PCI DSS ones. They're recommending that you protect your data, you protect your transaction, you have secure connections and things like that.
Just a quick question. So, where it was telling you all about your CICS regions, so you had your XDB2 and all that sort of stuff.
Yeah.
So obviously in ACF2 you have your ACF2 part. Override. Does it pull in those as well?
It doesn't pull in the. Oh, sorry. Yeah. The question is, what we've got is we've got the displayed the BACF SIP palms. We don't pull in the Broadcom palms, but Broadcom are equally able to hook into this mechanism.
Okay.
I'm not sure whether they've got a hook that they put in as yet, but they are able to put in hooks. And what you do, each of us write to an SMF record. It's the same SMF record, and that's sort of an open format record, so they can equally well put information into that. But I don't know their product. I try and avoid looking at competitors' products for obvious reasons.
I just wanted to check that it was pulling in the overrides. That's all.
Yes. Yeah. Parameters that aren't housed, we don't particularly look for that. The basic thing. I've reached the end of my hour. What was only a subset of what we produced in CICS. There's a whole series of things I won't go into there. That security, when I first joined, first became the lead in CICS a decade ago, was one of those things that was an overhead, and it's very difficult to get resources to do things. The environment has completely changed now, both within IBM and the general world. That security is really a hot topic on here, and we're investing very heavily to make it easier for you to implement security, diagnose security, and everything else. One thing to look out for is security request recording, if you've not seen that, as a way of diagnosing security problems on your system if they're difficult to diagnose. There's a whole lot more as well in the open beta, a lot to do with TLS 1.3 and things like that. So a lot to look for. And let's look for that information. 6.1 documentation, and as I said earlier, it's an open beta, and this presentation is very fresh. That was refreshed at 10 o'clock today, so this information is only 2 hours old. So it's the latest that we've got. So if you have a look on there, the open beta, that will describe things. Shortly there'll be code that backs up that as well, but the open beta's documentation will be there for you to have a look at, see all these other features. So any questions, any other questions?
I have one. So I'm asking this on behalf of another organisation, but so CICS user, is it still the case that you have to have minimal amounts of access? Is it like one transaction or something that needs access to? And two, should it have the protected attribute on so that it doesn't have a password?
It should have the protected attribute on so it doesn't have a password. In terms of the transaction definitions, we are desperately trying to get rid of them.
Okay.
There are some that are still required at the moment, they're in the books,
Right.
but obviously for zero trust, something that has no user identity shouldn't have any permissions to do anything other than open things like sign-on, stuff like that. So that should be the way of that's configured. So but definitely, yeah, you should not be able to sign on to that. Similarly, you should not be able to sign on to region IDs, because if you can sign on to one of those protected IDs,
Yes.
do it three times, get the password wrong, you take down the region.
Okay. Good to know, or not, as the case may be.
Yeah, I think that there's a few legacy things that we know about, and obviously we're trying to get rid of everything, because my aim is really to say, like the region user ID for Cat1 transactions, if you're the region user ID and it's a Cat1 transaction, the answer is yes. If you're anybody else, no. If you're a default user ID, the answer is no.
Right.
I don't mind what the question was, the answer is no.
Okay, okay. Very good. All right, Colin, thank you very much. So, I'm sure we'll have you back at some point again, Colin, with another update. That's brilliant. Thank you. So just three very quick things. So logistics now. So we're going to have a lunch break, 45 minutes. So we are running 10 minutes behind. So that will bring us up to like 12:55, which is summertime, folks, for returning back to the sessions. The second thing is that after we've had lunch, we're going to have the hints and tips session for 30 minutes. So be thinking about any questions, you know, what I mentioned at the beginning of the day, any conundrums, any technical, you know, things you want to have a discussion about. It could be non-technical. Maybe you're going to start a project and you want to know if anybody else has done it out there. And those are the type of questions, and also any enhancements that you want in you know, the vendor's products. Those are the kind of things we want to hear in the hints and tips. Third thing is, don't forget Al, our resident GSE social media expert. He's outside with his camera. So what he would like to do with some of you, including presenters and some of the attendees, just to get a quick 60-second, you know, recording of you, what you think about the sessions, what you think about GSE, those kind of things. He'll guide you through, don't worry. So if you're willing to participate in that, and you want some airtime in front of the camera, then he'll be out there, and we're very glad to hear from you. So we've now got buffet lunch. There's a choice of vegetarian. We're going for gluten-free, and there's also for the meat eaters. There's a buffet lunch out there, so help yourself. And if you don't fancy any of that, there's biscuits.
So that's going to be served in here.
Oh, it's going to be in here, is it?
We're going to put on the front table.
Oh, okay.
So, fresh drinks, tea, coffees, machine just outside.
Okay.
It asks everybody to stay in this room and kind of the foyer.
Sure. Then, okay. And for remote listeners, we're going to go quiet now. So we'll keep the Zoom session open so that you can keep yours open, but we're going to go on mute. You might hear some testing now and then, some voices, while we get prepared for the next session. So thank you very much, and we'll see you in 45 minutes.